If you were not in my class, go. Get out of here. What are you doing? Yeah, we're doing quantum chemistry. Yeah. E block? B block? Yes. And just hang out for quantum chemistry. Yes. We'll get a little Deepak Chopra. Or Deepak. You're welcome. Woo! See what we remember. It was amazing. That's what you remember. What? Why are you doing that? Why are you doing that? There's writing on it. I need that. Yeah, it shows me your organization. Why would you take that away? No, it's good. I want to see how you work. Yeah. I'm also observing and noting your hand. Excellent. Hazel, you do that anyway. No, like I taught you last year. I don't. Well, I'm not in your classes, so I can't say. But I would say it's probably just as hard now in this class, in my class, as it was in 2018. No? You think I'm marking harder now than I did in 20? What? No. Well, yeah. Well, to get a 5? Hold it. How old are you? No. I want to go back. What does 5 mean? Oh, it's out of 5. Okay, never mind. No, we used to have an effort rating system like 12 years ago, and 5 was the absolute best. Am I being recorded right now? because we're going to finish it hopefully this week. And what I'm really hoping is, not hoping, but I'm looking at maybe the end of next week. Because I want at least, I don't mind finishing the material and having the court test soon. Like we could finish on a Monday and have a test on a Friday. But I need at least one class in between. So you have one class to go, oh my God. Well, it depends. There's midterm coming up. November something. Yeah. Now, if you were feeling existential angst over it, at least in my class, you are going to get a mark out of 17. A reminder, that quiz does not count. It becomes formative if you do better on the test. And so I'm looking for any possible things that we can clear up before the test. So I'm marking it. It is now marked completely. Not everybody has written it. And I saw one person from this class who wrote it at break today. If you did not, I am going to put some copies if you haven't written it. Is there anybody else here who hasn't written it? Oh, and we've already talked. I'm going to put some extra copies in the test center for tonight. And then anybody who hasn't written it are just going to write it like at the beginning of next class for all the classes so I can give it back to you right away. Pardon? I'm not going to give you to today because there's people who haven't written it yet. And there's some people who won't write it for like a month, but I'll just make something different for them because they're away on medical leave. And I don't want to penalize you or them for that purpose. So last day, we did... we did quantum chemistry. Yep. And I'm just going to put this up. So, this referred to the energy levels. When you have first energy level, there's only one sublevel, and it is L is equal to 0. I was explaining this. I thought this would be a great opportunity, how complicated it is. So I explained it to an English teacher, Ms. Hedquist. And I said, okay, in the first energy level, N is equal to 1. And when N is equal to 1, L is equal to 0. But we have a nickname for L is equal to 0. We call it S. And then for N is equal to 2, L can be two things. It can be 0 or it can be 1. And our nicknames are S and P. And she said, that's nonsense. And I'm like, yeah, it kind of is. And she said, does this ever make sense? And I'm like, if you get to the area where you're doing calculations with it, it actually really helps. But we never do the calculations. But what helps is to remember these are like labels. S and P is like saying elephant and walrus. They're just a label. L is equal to 0 is the same as saying elephant. There are different ways that we can label it, and we're not going to use those numbers for calculations. But other people do calculations with them, so they set this up to make it easy to calculate here. The main thing we're going to do is shapes. So the first thing you're going to have to do right now is you're going to have to draw. Yep. SPD. Yep. And we're going to start. Nope. You can't be Mr. Collis. You can't say it's not proficient, it's fire or whatever he uses. You have to stick with what, because science is a common language. And one of the reasons they do that is so that scientists communicate. In any country you go that uses this particular alphabet, regardless if they speak Russian or German or anything, they will use the same symbols. They might have different names, but they use the same symbols for the elements. And the reason for that is when you communicate things that are poisonous or not poisonous in nature or explosive, you need to make sure you have it right. So there's certain things we don't change. So a lot of the labels don't change, even when you cross languages. They'll have very, very similar terms. So we're going to do, for the first example, the S orbital. And that is when L is equal to 0. So remember, those are both just labels. And then I want you to draw an axis. So that, like that. And if you don't have very much drawing talent, you can be rest assured that no matter how great your problems are in drawing, I assure you, mine are greater. You have seen my writing. So this is an axis. So this is coming out at you. So this is the x-axis, this is the z-axis, and this is going to be the y-axis. So this is the regular number line. Everybody's fine with that? X-axis. This is the regular y-axis. Everything's good with that? And then this is the axis in 3D that's pointing this way. Does that make sense? Samantha? That's Samantha. You were tilting your head and doing this. And when I see that on a student's face, I get a little worried. So it might help when I draw it on. The s orbital looks like a ball. So, oops. And I am going to try and freehand all of these rather than using my drawing tools, because that's not fair to those of you who don't have drawing tools. So I'm going to draw my best impression of a sphere. Ooh, I think that's the best one yet. Yes? Yeah, L is equal to 0. From last day, there, yeah, okay. Then I'm going to take this, because this is a sphere completely encapsulating Yep. How many of you take notes in pen? Stop it. Stop it. Pencil. All of science and math should be in pencil. Yeah, I don't. I'm going to take this one down to there, and I'm going to just pretend it moves in there. Boom. So that gives it a little, actually, if any of you are more artistically inclined than me, you're free to give advice as to how I should make this better. And I'm going to say that this actually moved in a little bit, so it gives that like, oh, it's puncturing it at that level kind of thing. And then this is a sphere, so it should have texture. I'm going to write sphere in letters. No, it's filled with an electron. So this is the first, each orbital sublevel fits 2 electrons. Up to 2 electrons. So this could be 1 electron, and it would fill that whole space. It could be 2 electrons. It would fill that whole space. Yep. And this is the 1s orbital. I am drawing the 1s. Yeah, the 2s would be the same. Oh, I'm going to draw the 2s in just a second. I'm going to make it bigger. King size. Well, it seems very sexist that queen size is always smaller. Regent size. And then the smaller one's commoner. And that's just classist. Oh, and I'll put this down for those of you who are trying. Ella? You have your phone out? Bring me your phone. I would walk over and get it, but I had much the same reaction. I always like looking at the cases, though. Oh, we use the math to predict the probability of where electrons are. So theirs will look a lot more dotted because it will have probability areas. Yep. Yeah. Or they'll use shading, depending on how they want to represent it. But is anybody going to object if I scroll down? Oh. Are you objecting because you just don't want me to do it, or you're not done? Okay. Yes. Yes. But it's a sphere. And I mean, if you can do this, There, you draw a sphere. It's good. Now you do need to have the yeah, you need your axes. No, these lines are I'm trying to give texture and lighting. Really? What? Oh. I have no drawing ability, so make yours look good. I'm trying to draw this at the bottom. That's a sphere. And say it's a sphere? Sure. Now the next, yes? What? It says sphere. Obviously. I didn't get my exclamation mark, though. It put it in an end quote and then a period, which kind of looks like an exclamation mark. Samantha, you good? It's a 1s orbital. Yeah. No, because this is L. It's L is equal to 0. So it is one of the L orbitals. Its name is S. It's the first one. Yes. Yep. Yep. It is a little. The labels are brand new to you. And I'm going to get rid of this because this is the professionally drawn version, and I said I would draw it with you. So, 1,000, 1,000. Oh, that was actually enough. I was kind of kidding. Oh, okay. So now I want to show the comparison without the axes, what a 1s, a 2s, and a 3s look like. And then a 1s is small, and a 2s, if you go up in energy levels, it is bigger. But it's the same thing. And a 3s is even bigger. Yep. Yep. They encapsulate. So the next one is yeah, well they encapsulate each other. So if I said yeah, what? Right. I've seen that game. I didn't know the name of that game. So there's the 1s. Here's the 2s. And I'll use a different color. This is a cutaway. I took a knife and cut it in half so we can see inside. I took the apple and cut it. We can see the core. So now, because when we just see the outside, we just see the 2s. But for this one, we see that there's the 1s and there's the 2s outside of it. So they're layered like an onion. Those are the different energy levels, and the S is the suborbital in each energy level. So they're orbitals. Yeah, they're all orbitals. Yeah, they're all orbitals. Yep. Hands. Pardon? Yes, it is an orbital. Is this? That's the electron cloud. Yep. A place where electrons reside. Oh, no, no, no. There's p orbitals and d orbitals. Yep. Its shape. Yep. Yep. I'm not going to do what we are doing next until I do it, because I want people to finish this. Yep. Well, then use. I mean, you don't have to do different colors. I'm doing it so that everybody can see. But if you were colorblind, you'd have to just go by the position. I think Ms. Legasic still doesn't know what the house colors are. So each one is encapsulating the other. This is a lot like Bohr. So if you're like, what is going on? Well, in Bohr, if you want to compare, don't write this down. In Bohr, we had the nucleus, and then we had 2 electrons, and then we had 8 electrons. I don't know why I drew that like that. And then we had another 8 electrons, and they encapsulated each one. And I said that they go around in spheres. So it is the same as Bohr. We're just being really intentional about the 3D shape, and I'm about to show you different shapes. Yes. Well, no, hands only, please. Yes. Oh, it's a cutaway cross section. Nice one. Cross section. Hands? No, but you can't start speaking until I call on you. No, you're still talking though. Yes, hand. In the S, 2 fit in every orbital. F? Oh, 2 fit in every orbital. But in the F, there are 7 versions. P has 3 versions. D has 5. And S only has 1. So S only has 1 orbital, so we can do the different energy levels and notice that it gets bigger and bigger. Yeah. Oh, we're going to get to that. We're going to do the shapes first, and then then we're going to do that. Pardon? Each one can only fit 2, but I'll show you in the next one how it works out. I can give you a little preview. Yeah, but the S orbital only fits 2, right? How many fit in the first energy level in a Bohr atom? 2, and that's an energy level 1. There is only S. That's the only suborbital, so it only fits 2, and that makes sense. But now, yeah. I was about to go to the next page. Yes, Ella? Yeah. In fact, I do all of them separately, but actually in the real atom, they're all mushed together. It's a bit like if you're studying the circulatory system, you may look at veins and then arteries, and you have different diagrams, but really in the human body, they're over mushed on top of each other. Yeah. Good? Anybody still ready? Hold on. 5, 4. Yes, Emiliano. It was Bohr? No, Bohr's is an incorrect. He has errors in his that cannot be accounted for. What? Oh, it was more. Yeah, it was more right than the previous ones, because it include this layering as well. Yeah, and the fact they're on the outside and can freely move around. Well, when you say just a theory, remember, science doesn't work by proving things. Science isn't making a painting. You don't add things. Science is a sculpture. You disprove the things that are wrong and you take them away. And what you're left with is the image. And that's what we assume is true. So, just to finish that question. So, when you say are there lines of evidence supporting this? There's so much evidence supporting this. Right down to the reason we teach it is because the shapes of these atoms and their orbitals tells us how they're going to bond together way better than Bohr ever could. But could something new come up that would replace it? Sure. But it would also have to include all this. So this not only explains Bohr, it explains new stuff. Does that make sense? Science is a very practical method of finding out the truth, because the truth in science is not big T truth, it's small t truth. It's the stuff that works. Big T truth, philosophical questions, can't be answered with empiricism, because you're just taking away what you don't know. You're disproving things. Okay, we need 3 axes, and we're going to label them slightly different. And this is going to be so exciting. Now we're doing We are doing the P subshells, or L is equal to 1. And there are 3 subshells. And we're doing our axes like this: Z, X, and Y. And we're going to keep them that way for all of this. Yeah, yeah. The only thing I want you to get out of this right now is what the shapes are. Yeah. One second. What is L? So for the first energy level, L can only equal 0, right? We did that last day? Okay. So the number of suborbitals in each energy level is given by N. So at the second energy level, you have L, and L is equal to 0, like it was before, and 1. We gave them nicknames. L is equal to 0 is called S, and L is equal to 1 is called P. We're doing the P orbitals. Now, for your question, was it your question? Who asked about the 288 rule? Right, there, sorry. So for here, there are 3. How many electrons would fit in that? If 2 fit in each one. No, I'm asking Sophie. 6. And remember, in this level, L is equal to 1, but there's also an S. That fits 2. So now we have 2 plus 6. That gives us our 8. Now, your question, why did I change the axes? And the answer is because I can. Oh, you do. Yeah. And I'm even going to make them a bit more, I'm going to make them a bit more 3D. So I'm going to make this a dashed line to show that it's going away from us. And I'm going to thicken this line to show that it's coming out towards us. Because I want to emphasize that this is coming out of the board. And I switched the x-axis from down here to up there. Because I can. And literally because I can. Why is this always the x-axis? Yeah, it can be. It was in the first graph. But in math, you often have this one as the x-axis. Nope, I do not want you to. And your examples will be wrong if you do that, unless you adjust every example I do. Well, because I'm about to show you the labeling and the thing that goes with it. That's just... In math, most often, what are you solving for? You're solving for x. And so they often put it there because they want the easiest one there. In chemistry, we are not often solving for x. You could be solving for x, y, or z. All of them are equally important. 3D, that's the 3D space that's important, not this. You can label it in any way you want, and I wanted to do it this way because it actually doesn't matter how we label it, in the sense that if I labeled this differently, I would come up with the exact same 3 drawings. But if I labeled this x, you would think, well, that's because x is supposed to be there. It's not. You can relabel things if you need it, and I'll show you a little bit more of that once we do it. The reason you can get it wrong now once it's labeled is because I am going to do first what's called the py orbital. So this is py. And because it exists at the second energy level, we'll draw the 2py. So that's the second energy level py. And if I said I want you to draw the 5py, you just draw it bigger. And this orbital comes out like this. That's a terrible bulb. I'm going to try better. Be better. Be better, Mr. Neufeld. There we go. Yep. Yep. And now they completely they're on, it's called Y because it encapsulates the Y axis. Oh, one question at a time. You can draw it any size you like, but it has to be visible on your page. We're not comparing it to anything else. So if you were comparing it to like a third energy level, it would have to be smaller. Next question. There you go. So that's the PY orbital. It's along the Y axis. So, hold it, where'd my phone? There it is. Class Dojo. Class. There it is. Random. Morgan's not here. Jensa. On the next one, I am going to draw the PZ orbital. Knowing that this is the PY, how would you draw the PZ? Yeah. What? No, it's exactly the same size. Now that you say that, I feel obligated to do this. Oops. How did I do that? Didn't I clone that? There, I did. Stop it. Put that back in. They're still in the second energy level, Emiliano, so that's why they'd be the same size. That we're not doing like the third one or anything. And, come on. What am I doing? I want to draw, and I want it to be white in color, so I can color that out. And I'll just go like that. Do the same thing. Out and give it some texture to show that it's bulbous. Draw the PZ. And that means you have to label your axes properly. Now, could I have labeled this one where the Z is the horizontal one and then that's the PZ? Absolutely. Yeah, you can just draw it sideways. But I want us to see the three different modes, so I'm fixing it. Yes, sir. No, if it was 1P, it wouldn't exist. Because in the first energy level, there's only one, can only be 0. So this is all for L is equal to 1. So you can only have it in the second energy level. If it was the third energy level, where you have L is equal to 0, 1, and 2, then for the p orbitals, they would just be exactly the same. They'd just be a little bit bigger. So for the Z, this is going to now be the 2p x. This one should be coming out at you. Oops. So this should come out at you like this. And it should be a little bigger because it's coming out. They're still the same size, but perspective-wise, we want to see that difference. If I can't see which axis is on, then it's not fine. Yeah. Now, but on an exam, you can change your axes. So you could draw this one for all of them, this one here, but you could, oops. If I wanted this one to be the PX, I would just go like this. Oops. Now it's the PX. Perspective. So one is bigger because, here's my little balloons. This is Py. This is Pz. But now I have to turn this into the board. This is Px. And this balloon is coming at you, so I want to show graphically that this is bigger. Not because it is bigger, but because it's closer to you. And this is smaller because it's farther away. So I'm trying to get across the three-dimensionality on two-dimensional paper. And this is an important skill in chemistry. Because we do a lot with three-dimensional models of atoms and molecules and eventually proteins. Because looking at how they bond and their structure figures out how they're going to react. So that's why that one's bigger. Now, what I want you to do now Ella, come get your phone. And everybody take out their phone and download the Class Dojo app. Class Dojo app. Because people didn't want to have to do. Now, when it asks you to log in, first of all, say that you're a student, obviously. And when it asks you to sign in with a QR code. I have an individualized QR code for every one of you. So you have to come up here. I'll give you your QR code. Use that to sign in. And as you come up, just tell me your first name quickly so I can look it up. There you go. There you go. What was wrong with that? It's signing in. There you go. Oh, that's yours. I know. There you go. SAI? Yes, perfect. Good. No. How did you get Samantha's? See what it does. There we go. No, that's Emiliana. Maybe give me your last name, because a lot of people seem to share some things in common with each other with first names. I think there's only one, and nobody shares Jacob. It's in a different class. There you go. There you go. Nice. Nice. There you go. There you go. Yes, absolutely. Oh, nope. Oh, right. There you go. Sorry. Hold it. No, that's not you. Get it. Last name. Oh, yeah. little. And can you log out? There you go. You're a student. There you go. There you go. There you go. Now you can change what your little monster looks like if you'd like. GOTH. There. Excellent. There you go. Excellent. So, now that you have this, what I would like to use it for right now is you can add to a portfolio. I would like you to take a picture of your 3 drawings and submit it to your portfolio on Google, not Google, on Class Dojo. No, I want it like proper. Yeah, create new photo and then add it to your portfolio. Nothing. You don't have to say anything. You just have to take a picture. I want to see them start popping up. Yeah, I want the 3P orbitals. Your 3 drawings. Just a new post. Yeah. Nice. Excellent. I am improving Ella's. Well done. Oh, Max. Excellent. Improving it. Yeah. Jacobs. Beautiful. Approve. It's a photo. Yeah, they'll all be pending until I approve them. Nice. Yeah, you just take a photo. Jensa. Approved. And that one looks good, that one looks good, that one looks good. I've got more approvals. How many people are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 plus Daisy. So we are still missing a bunch. Nope. There comes in Ona. Oh, that's a nice drawing. Excellent. Hazel. Ooh, nice one, Hazel. I like the exaggeration on the on the last one. Yeah. Oh. Samantha is clearly more artistic than I am. Well done. 1, 2, 3. So, do I have Max's? Yes, I do. Do I have Ian's? Ian, I don't seem to have yours yet. Oh, no, just found it. Popped up. Yep. Jacob. Yep, got Jacob's. And then, whoop. Yager. Got yours. And Samantha. Not Jax. Davis, yep. Hazel. Jensa. Riley. Sophie. They look good. It's art. It's clearly art. And then do I have Daisy's? Where's Daisy? Daisy's not here and I don't have them. Emiliano, do I have yours? Yes, I do. Ona, do I have yours? Yes, I do. And Sahage, do I have you? What are you doing? Yeah, that's taking a picture. Oh. And Emily. Oh, that, yeah, I've got yours. So I'm only missing Daisy, who's not here. She has clearly just left. Okay. The purpose of this is that now that you have it, I'm taking a little time to do it. One, it gives you a break from all the drawing that we've been doing right now before we go on to the next section. And two, I can ask you for a sample where I can give you feedback, proficient extending, and all that stuff we're supposed to do. That is quick in class. I don't have to, if I walk to your desk, I lose all that walking time. And if I start here, I usually don't get to there. If I start there, I don't get to here. Whereas here, I can see them as you're done, and I can quickly see approve, disapprove, return, delete, and get those in. Daisy, can you take a picture? Did you get your Class Dojo app? Did you take a picture of your 3 orbitals? If you could take a picture of your 3 orbitals as a new item into your portfolio. You were the last one. Yep. Yep. The x-axis is going this way. Straight out. Straight out. But we can't draw it straight out because then it would just be a point. So we draw it like this. In the same way that if we want to draw a 3-dimensional box, we don't draw a 3-dimensional box by doing this. We do it like that in order to show sort of size and shape. And that's a terrible box. But if I rotate that box and I just have this, I haven't shown anything meaningful in terms of 3D. So yeah, we've rotated it slightly in order to show it. Yes. Of you? I think I can change it. Oh, if you send me an email to do that, I can. I could change it in Class Dojo. Here's the computer drawings of the same thing, just so you have a better sense of the 3D, because I'm not that great at drawing. But there's the X. Notice they're using the same ones. There's the Y. There's the Z. And we're rotating it. Now, joy of joys, we get to do the D orbitals. No. Not oh no. Not that we have to. We get to. Hold it. What grade's your sister in? I get to. Perfect. Okay. The D subshells. And this is for L is equal to 2. And for this one, been drawn in purple. We're going to label it again. No, we're going to need 5 in total. Yeah. And I am once again coming to you to ask for your support. No, there's going to be 5. And we're going to need it a little thicker to show that it's coming out at us. One. Does that make sense? Okay. And for this one, the orbitals, gotta get it right. We should get Samantha up here to draw them all. I didn't like the size of my drawing. Yep. I'm cheating a little bit. My apologies. But I saw my drawings and I said, Mr. Neufeld, you suck. Do what you can to make it better for the students. When I was in grade 7, I was in the choir because you had to be. It's not like you had a choice. Yeah, you got to. And when we came to the day where you have to sing to your parents, like our concert, the teacher told me to do this. And to make sure no sound came out. Harsh criticism. And I think of that every time I criticize my drawings. Now, for all of these, this is in the plane of the... Oh, I didn't label the axes. I am so sorry. The axes are the same as before. This is X. This is Y. And this is Z. And... if I'm going to put some directionality on this, I'm going to color over that, or I'm going to send it back. Why don't I just send it back? Oh, it doesn't allow me to do that. So I'm going to take the color and make sure I get rid of that, because this is in behind this axis. Because this... now, it is very definitely over top of that one. You can't see it through it, so I'm going to color that one. Beautiful, beautiful. Today's the day we become an art class. So we can see that this is covering up visually that axis, and we can see that this one's coming out of this. This one is in the plane of ZY, because this particular one, is that Jens's hand? Yeah. 0. This is 3D Y Z. Obviously it is. Yes, they're all supposed to be the same size. To show that you can see the axes on top of it. And then I'll just color this one and color the other one for consistency. The petals, the shape is independent of the number. The shape is, I don't want to say arbitrary, because it's, sorry? This is the third level. There could be one electron in this, but it would have all 4 petals. It looks different. When you said how is it different than the first level only had a sphere. This has 4 petals. Sure, of course you have to color them. Yep. So I drew it this way because the axis is coming out, but the petals are not. It's flat against the board. It's still 3D. So in this equivalent, I'm only going to take 2. I'll take 4 later. This is the equivalent. These are like in line with Y and Z. So here's Y and Z. X is coming out at us. So this is like this. Now, if X is coming out at us, then that would cover this petal. And those ones are there. So these are in the plane of the board. That's that axis. This is the 3D axis coming out this way. The petals are still like balls, but they're not. It's not going this way. It's going this way and that way. Yeah. Does that make sense? Yes, Jacob. Not YZX? Oh, because it's in the plane of YZ. If X is coming out, so we're going to do that one. It's not coming out of the page. It's like this. If it was coming out of the page, it'd be like that. And then, and yeah. Well, obviously, because we're drawing it. But we're representing a three-dimensional object. There are 4 lobes, like this, and like that. But I'm not doing all 4, because it's complicated to try and fit 4 things in my hand. Although, it is possible. See? Complicated. If it pops now, I'm going to be very upset. So this is what a d orbital looks like. And in this case, it looks like this. Not like that. Not like this. Like that. In the plane of z, y. Pardon? What do you mean x is more elevated? Why is that so heavily? Because x is coming out, if I put it this way, x is coming out like this. So because I've drawn it at an angle, it would be covering up that lobe, right? So you can see the axis would come out over top of it. In terms of drawing something with perspective, the axis is coming out at you while the lobe is staying in the back. Does that make sense? Sure. That sound. Well, no, the next one I'm going to do. Well, sure, but we're going to draw all 5 of these, and we're going to keep the axes, so it doesn't matter where we start. The next one we're going to do is the 3D XZ. So now we'll see the difference. And this is the X, this is the Y, and this is the Z again. And in this case, here's what we're going to do. Is I am going to take this, right? It's this way right now. So for the next one, it has to be taken, and you have to draw it like this. These 2 lobes are coming out at you above and below x and going away from you above and below x in the XZ plane. I want you to draw that and take a picture using the class dojo once you've drawn it. I'm going to make, but now don't just take a picture yet, because I'm going to make a little assignment on there. Yeah, so this is rotating towards you. Yeah, like right here. Yes? So right now, the first one you drew was like this, right? The next one you draw is this. Okay? Yeah, watch. The first one you drew is like this. The next one you draw has to be represented on the page like this. No, because remember, this is on an angle. So it's not literally like this, it's actually kind of like that. These 2 are coming out at you, and these 2 are a little farther away. So perspective-wise, these should reflect that. Okay? And I'm going to set up on here. I can create an activity. I will call it 3D XZ photo of your drawing. And I've just posted an assignment to Class Dojo in which you can now post your particular picture of that. I want to see I'm not going to draw it first. I want to see your version. And if I don't like it, I'm going to delete it and tell you to do it again. Just submit it and find out. Oh, Hazel, I like yours. Approved. In fact, one of the reasons I like doing this is I can now, and rather than me drawing everything, I can now go like this and go, hey, here's Hazel's version. That's fantastic. I'm going to do that. That's I got Sahaj. Sahaj, yours is okay, but your angles are off to where the axis is. It's angled the wrong way. And they're so close together, I can't really tell them apart. So I'm going to get rid of that one. You can submit a different one. Oh, there's Yager's. Yeah. Well, it depends on I'd have to take a look at it. Submit it. Yager, yours is good, and I like the use of the color to show that it's coming out. But it's angled. It should be, in terms of it, I'm improving it, but the angle is a little off. But yeah, Max, I can see that. That looks good. Yep, Sophie, that looks good. Hazel. Oh, Hazel, I didn't even approve yours. What am I doing? Ian. Now, there's a couple of these, and I approved them, but there's a couple that look like this. I'm going to draw it. There's a couple that look like, I won't say who it is because I'm offering criticism, so you don't have to offer anything. But ones that look like this do show it, but my worry, and this is more the one, the other ones were emphasized a little different, so I approved them at first, but the worry is that this looks like a little, that this side is a small and this side is big, but not that they're coming out at you, just that you have two different sizes. And you want to really show that it's a rotation. So just be a little careful with that. If you see it, because perspective is also a matter of perspective, I'm going to, they're good. But just make sure you don't get that. Ooh, that's a nice computer one. Yes. Pardon? Oh, 1 second. I already did. Just reload your page. It should work. Samantha? Soon as I get it. Jensa, like that one. Jacob. Oh, you angled it like that. I don't know if you're two that are supposed to be going away. They look really close to the same size. So it doesn't give me the sense that they're going away very much. Fix that. I'm going to no, I just deleted it. Oh, that's interesting. So I can't tell what the pairing is there. I am going to take this one, and this is another one. I think there's a so I won't call you out because it's not a quick one. But this one, I'm not sure I see the 3D nature of it because it looks like, although I could, but it's hard for me to tell because these are colored the same. I don't know which ones are supposed to be going away. Now, if these two are supposed to be going away and these two are coming towards me and they're angled like that, I think the shading might be throwing me off. You see it though, Jensa? And I think what it is that to me they look a little one's straight, the other's curved, and the pairing isn't quite right. But if you see it and your drawing is good, then it's okay. I'm going to approve it, but as long as you see it. But that one's, I think what throws me off is they're identical in size. That's what it is. Because they're so identical in size, I can't tell which one's going away. So use sizing to show perspective. I need Mr. Luna here. Oh, I should invite Mr. Luna to a chemistry class to teach perspective, because I am terrible at this. Ella, that looks good. Sahaj, I guess it worked. Oh, that looks great. Jacob, that other one now looks really good. Emiliano, it looks really flat. You've done shading to show direction, but I think you could use more size. Just a bit more emphasis on size. Emily, that looks great. Now, everybody's done it at least once now. And I think I'm going to take that one. Why are you charging your iPhone? You wouldn't even know that it died out. Oh, my entire statement is removed by the fact that what you just said made so much sense. Mm-hmm. Order, bring to front. There we go. So for our next example, for the 3D XZ, I'm just going to use the one I got at the beginning. That way I don't have to draw it again. So thank you, Hazel. We can see the two lobes going away, two lobes going in here. Is there anybody who needs more time on that? If you haven't submitted your picture yet, I got rid of it and you haven't uploaded it, please do that tonight. I am going to go through them again later. Okay. I have no idea what you're saying. So, oh, I see what. Yeah, okay. Different people are going to do different things for perspective. Actually, now that you say that, I never thought about that. You could, to show perspective in what was just asked, and I don't know if this makes more sense or not, is that you could cover that up. That's not quite the same color. That's not quite the same color. It's closer, though. Because it's in front of the axis is what you're saying. Does that allow you to see it better? Then do that. I could see it either way because of the sizing, but that works too. Because you're saying it's coming out at you and it's in that plane. Yeah. Yeah, resubmit it. Oh, sometimes it just takes time for it to upload. Oh. I wasn't looking at the labeling being correct. So, yeah, it just hasn't uploaded yet. If it's submitted, it's going to their servers, then it has to come down to me, and so I'll get a little bit later. I think you can upload another one, like you can add more. So just fix it, and let's double check the labeling on here. We got Z, Y, and X. Okay. I do, however, want to start the next one, because we are going to finish these. We have 3 more to do. We don't have 5 minutes. We have like 10 minutes. Well, then let's go quick. We have X, Y, and Z. And this is going to be a flat planar one again. This is the 3DXY. 3. So now did I? I don't know. Oh. There we go. Sometimes I do that. So we had this way, right? And now we had this way. This one's this way. Yeah. 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 Yeah, perspective. All that fun stuff. So how I'm going to do it, and this one I'll suffer with you, and I won't have you submit it, is that this side is like, it's the way of perspective, this side is going to be really big. So I'm going to draw like a big lobe out here, and then it should be a slightly, but it's going a little away for you in there, and then it would be like a little one that way, a little one that way, and then what do you mean inside what lines? 3D XY, yeah. Well, in any question that says whether you're doing chemistry or history or social studies, when are we going to, and the answer is if you don't learn it, never. Does this fundamentally affect the shape of molecules and affect how they bonding if you go on in chemistry? Absolutely. And if you ever, I can try and relate it and say, well, if you ever hear a news story about chemistry stuff, then you'll understand a little bit more. But practically, this is training your brain how to think how the real world actually works. Like, this is actually our closest approximation of how atoms work. And so being able to think in that way, is it just in itself useful? I'm keeping the axis the same in every time. Oh, it has to do with spacing. All 5 of these d orbitals exist at the same time in the same atom. Yeah. Yes? Okay, well, I'll show you. You're trying to show it in the horizontal plane coming out at you. Did that work? Not the vertical plane coming out at you. Yeah, then if you got that, you're good. In my mind, no. But I don't draw perspective for a living either. I just draw it in little bits. So we had this, right? And then we had this. Is yours like this? Then it's good. Oh, because I rotated it. I have these intended to be these 2 in the front coming out at you. Well, because then you just see 2 circles. Yeah, show me what you got. Oh. I did it at an angle. I like your perspective. And what it's really showing is that these 2 are coming straight out at you, right? But this axis is not coming straight out at you. It's at a slight angle. So I overcompensated for this to exaggerate the fact that this is slightly diagonal. You have done it as if they are both coming straight out at you and shows that. And it still shows it really well. There's nothing wrong with your drawing. Remember, I am an amateur drawing person who can draw just barely enough to draw blobs. And not necessarily good blobs. Next one, and this one will be a little easier. This is the 3D x squared minus y squared. It's actually a dash, not a minus. Now this one looks a lot like our first one. Remember this first one? Rotate it. It's except it is in line with the axes. Did I? I do that every time. Why do I do that? The axes are not supposed to change, just so you know. Yeah. Oh, sorry. I can fix that. The dash, it's going away from you. I'll put it on. I'm just doing the dashed lines people were complaining about. The Z is in the same spot as all the other ones. And I know it feels really complicated right now. I really want to really strongly emphasize it's just shapes. It is precise shapes. But what we have is a ball, a dumbbell, and a butterfly. And we're just rotating them. Yeah. Well, hands, not calling out. Samantha, do you need a moment? No, Emiliano, I didn't call on your hand. Ella's been very patient. Yes, Ella. Oh, yeah, I will. Yeah. But I really do want you to draw them. Because I don't feel you really understand something that's three-dimensional until you've either sculpted it or drawn it in some way. Yes, Emiliano. Sorry? No, they're all 3D. They're all 3D. Yeah. There, 3D. There, that's my attempt at 3D. Oh, that'd be awesome. I don't have clay, though. Might be. Okay, the last one. Is everybody ready for the last one? Ready for the last one? I love the last one. Because after all... Now, notice this is the dx squared minus y squared. The reason for that is it's the second xy. And as the second xy, because there was already a y z up here, x, hold it. Oh, you confused me. To make this easier to draw, I did deliberately change the axes. Yeah. Stop complaining about my changing the axes. I was right all along. This is x. It's along the xy. Yeah. Otherwise, you'd have to draw it coming out at you again. And at this point, I decided to I changed it. Yeah, I changed it up on you. I was getting so panicked because everybody's getting confused. I was like, oh my God, I did it. I made a mistake. Always, I got to remember, I don't make mistakes. I'm always right. The last one's amazing. This will easily be your favorite. How else could we rotate this? We've done all the different positions. So the last one, this is mathematically the same as all the other ones. So first we just do two lobes, just two. Oh, the name for this is dz squared. And this is z, y, and x. Pardon? 3dz squared. Yeah, it could be 3, it could be 4. 1 1,000, 2 1,000, 3 1,000. Okay. I'll go back up again. I just want to show the last one. Naturally, the other two lobes, the only place left is for them to be a donut. They go around it. And I'm just using different colors to emphasize it. It's a ring. It goes around it, and it doesn't touch the middle one. This allows bonding to get to, Riley, your question. This tells us if it's using this, it'll bond top and bottom and anywhere around the ring. So you can get molecules that bond this way and then can have satellites all the way around the other way. And it doesn't matter where they are. I can fit a lot of them. That's on the, no, the Z-axis. Yeah. Yeah, and the things around it. Well, we wouldn't want to overcorrect, but make sure it is Z. We're in Canada, and some people are only speak American and are a little ESL. So. Oh, no, it's recorded. It's recorded and broadcast live. But it's recorded. Riley, I feel now my heart is so. Oh. You need a charger. But you still need, like during like in this class, you could sit somewhere where you could charge it while you're using it. That's the other two lobes. That donut is the other two lobes. Mathematically, that's where they go. Yeah. Now, I'll talk more about it next day. I'll talk about do you have to be able to draw all the d orbitals? No. You will have to be able to recognize them. You will be expected to draw the S and the P. Yeah. Maybe next week. Like what? Did you say streaks? Oh, it might be next week. No, stop doing that. Okay, well, that's good. It might be that you write later then or something. Isn't that the best orbital? See? He loves it. He's a fan. It's drawn so well, he says. He's in AP Chem 12. Pardon? I don't teach Chem 12 AP. I am grade 11 only this year. Sorry. Test. Pardon? On Friday? Yes, I absolutely will be.